There is a product sitting on Amazon right now, priced between $12 and $18, that carries a secret more valuable than anything else on that page. It looks unremarkable, thin, silvery, almost translucent. Most people scroll past it. The listing calls it window film or solar control film, and it sits buried beneath pages of phone cases and kitchen gadgets. But if you knew what it actually was, where it came from, who uses it, and who decided you shouldn't know about it, you would stop scrolling immediately. Because this is the technology that slashes energy bills by up to 80%, and the energy industry has spent decades making sure it stays invisible. Let's start with a number: $60 billion. That is the approximate annual profit generated by the top 10 U.S. electric utility companies. Every dollar of that profit depends on one simple assumption: that you will keep paying your monthly electricity bill, month after month, without question, forever.
Now ask yourself, what happens to that number if millions of American homeowners suddenly cut their cooling costs by 80%? The math is not complicated. The motive is not complicated. What is complicated, deliberately, carefully, expensively complicated, is the information landscape that surrounds a technology that has been technically available to the public for over 5 decades. You were not supposed to find out about this, not because it doesn't work, but precisely because it does. The summer of 1972 in Houston, Texas, was not a summer for the faint of heart. The city baked under a relentless southern sun with temperatures regularly breaching 105-degree Fahrenheit. For most Houstonians, this was just miserable. For the engineers at NASA's Johnson Space Center, the facility that had just 3 years earlier guided humans to the moon and back, it was a problem that demanded a solution. The Johnson Space Center's facilities were absorbing enormous amounts of solar energy through their windows. Glass, it turns out, is a remarkably poor defender against the sun. Standard window glass allows the vast majority of solar radiation to pass straight through, converting light into heat the moment it hits the interior: desks, floors, walls, people. The result was a building that air conditioning systems struggled to manage, consuming massive amounts of energy in a losing battle against the Texas sky. NASA's engineers were not accustomed to losing battles. They set to work on a solution, and what they produced was something quietly revolutionary: a thin, metallic film that could be applied directly to existing glass surfaces. The mechanism was elegant in its simplicity. The film used microscopic layers of metallic particles, suspended in a polymer matrix, to reflect and absorb solar radiation before it could penetrate the glass. The sun's energy was being met at the door and turned away, rather than allowed inside to wreak havoc. The material they developed would come to be classified under the broader category of spectrally selective coatings, engineered surfaces designed to allow visible light through while blocking the infrared radiation responsible for heat gain. But in 1972, it had a more straightforward name inside the walls of Johnson Space Center. They called it metallic thin film. Science without documentation is just storytelling. NASA, being NASA, documented everything. In the research literature that followed, the technology note designation TND 7492 would become the formal record of what metallic thin film could do. The findings, when stripped of their technical language, were staggering in their implications. The film, when applied to standard glass, was capable of blocking 78% of incoming solar radiation at the window surface itself before that energy ever entered the building. Not 20%, not 40%, 78%. To understand what that number means in practical terms, consider this. The majority of a home or office building's cooling load in a warm climate comes directly from solar heat gain through windows. Air conditioning systems are essentially fighting the sun through the glass. Remove 78% of that solar energy at the source, and you have fundamentally changed the thermal equation of the entire building. The report did not speculate about this, it measured it. The data was there, published, official, and stamped with the authority of the American space program at the height of its credibility. Here is where the story takes a turn that is difficult to explain away with bureaucratic inertia or simple market dynamics. By the early 1980s, metallic thin film, and the broader category of spectrally selective window films it had helped pioneer, was being systematically installed across government infrastructure in the United States, federal office buildings, military facilities, state government complexes. The technology moved quietly through institutional channels, saving taxpayer-funded energy budgets millions of dollars annually. The government, in other words, knew. It adopted the technology. It benefited from the technology. And in doing so, it created a stark and remarkable division. On one side of that divide, institutions with access to scientific research networks, procurement systems, and facility management professionals who read technical literature. On the other side, ordinary homeowners, renters, and small business owners, people whose windows faced the same sun, whose air conditioning fought the same battle, and who received no memo, no public awareness campaign, no consumer-facing version of the technology they were already funding through their taxes. The residential market as an industry category was left in the dark. Was this a conspiracy in the dramatic, shadowy sense of the word? Perhaps not. Conspiracies rarely require a room full of villains. They require only a set of incentives pointing in the same direction, and nobody with enough motivation to push back. The utility companies had every incentive to ensure that residential customers remained dependent on the grid. The window industry had every incentive to sell new, expensive, energy-efficient window units rather than a $15 retrofit film. The air conditioning industry had every incentive to keep cooling loads high and replacement cycles frequent. None of these industries needed to coordinate. They simply needed to not promote a solution that was bad for their business models, and so they didn't. The remarkable thing about the present moment is not that the technology was hidden, it's that it stopped being hidden, and almost nobody noticed. Metallic thin film in its modern commercial form is available today through mainstream consumer retail channels. Amazon, hardware stores, window specialty shops. The product has evolved in its application ease and optical clarity since 1972, but the underlying physics is the same. The 78% solar radiation blocking that NASA documented still applies. The price point that would have seemed impossible for an energy-saving technology of this caliber, roughly $15 for a standard window application, reflects nothing more than 50 years of manufacturing maturity and competitive retail pressure. The technology has been sitting there, waiting, not in a classified file, not behind a corporate paywall, on a product page, in a cardboard sleeve, with a 2-day delivery option. The question was never whether this solution existed. The question was whether you would be told about it. You weren't. Until now. That diagram above is not abstract theory. It is what is happening right now in real time through every unprotected window in your home. Let's break down exactly what you're looking at and why it's costing you hundreds of dollars every year. Most people assume glass blocks sunlight. It doesn't. Glass is, by its very nature, a traitor to your comfort. When a beam of solar radiation, carrying both visible light and invisible infrared energy, strikes an ordinary single or double-pane window, 3 things happen simultaneously at the molecular level. First, a small fraction of the light is reflected back outward. For standard clear glass, this is roughly 8% of incoming solar energy. A pittance. Not nearly enough to matter. Second, the glass itself absorbs some of the radiation, around 14%, directly into its molecular structure, warming the pane itself. You've felt this. Touch your window on a sunny afternoon. It's hot. That heat doesn't stay in the glass. It radiates inward into your room and outward into your face when you stand near it. Third, and this is the catastrophic part, the remaining energy is transmitted straight through the glass and into your interior space. For a standard, untreated window, that number sits at approximately 78% of all incoming solar radiation. 3/4 of the sun's assault on your home walks right through your windows as if the glass wasn't there at all. This is not a manufacturing defect. This is not something that better quality glass fully solves. It is the fundamental optical physics of silica-based transparent material. Glass was designed to let light through. It does its job perfectly. Unfortunately, its job is destroying yours. Here is the number that should make you sit down. Research compiled at the Lawrence Berkeley National Laboratory established that an unshaded window in direct sunlight delivers approximately 250 BTUs of heat per square foot per hour into the interior space behind it. 250 BTUs per square foot per hour. Run that through the conversion math and you arrive at a figure that is genuinely difficult to absorb. A single standard window, roughly 4 feet wide and 4 feet tall, 16 square feet, is generating the thermal equivalent of a 1,000-watt electric space heater running continuously for every hour that window is in direct sunlight. Picture that. Not a subtle warmth, not a gentle solar contribution to your room's temperature. A full kilowatt of electric heating, the kind that glows red when you plug it in, blazing silently and invisibly through every unshaded window in your home, day after day, all summer long. Now count your windows. The average American home has between 8 and 15 windows, even conservatively assuming half of them receive meaningful direct sun at any given time. That's 4 to 7 invisible 1,000-watt heaters running inside your house. Your air conditioning system spins up, strains, cycles, and strains again. Not because of the temperature outside, but because of the thermal assault being conducted from inside your own walls. For decades, the home improvement conversation has been dominated by insulation, better attic insulation, thicker wall insulation, sealed door frames, and none of that advice is wrong, but it is dramatically incomplete because it consistently omits the single largest source of summer heat gain in a typical home. The U.S. Department of Energy's data on residential heat gain is unambiguous. Approximately 40% of a home's total summer heat load enters through the windows. Not through the roof, not through the walls, through the glass. Think about what this means in practical terms. You could insulate your attic to the specifications of a Scandinavian passive house. You could wrap your walls in 3 inches of spray foam. You could seal every door frame with surgical precision. And you would still be leaving the biggest open door in your home untouched, because the windows, accounting for nearly half of all your summer heat problems, sit there unaddressed. Walls and doors, combined, account for roughly 30% of heat entry. The roof and ceiling together contribute about 20%. The floor and miscellaneous sources make up the remaining 10%. This means your windows are generating more heat gain than your entire roof and all your walls combined. Yet, when a homeowner calls an HVAC technician because their air conditioning is struggling, the first recommendation is almost never treat your windows. It's a bigger AC unit, which is, from a certain business perspective, a far more satisfying solution. Here is a reframe that may permanently change how you think about your home's climate control. Your air conditioning system was designed to fight the outside temperature. When the thermostat reads 95-degree Celsius outside and 74-degree Celsius inside, your AC measures that 21-degree gap and works to maintain it. That's the battle it was engineered for, a slow, manageable thermal gradient between inside and outside, mediated by your insulated walls, your sealed attic, your weather-stripped doors. But that is not the battle it is actually fighting. The real battle your AC is losing is happening inside your own home, launched by your own windows, right now. Every square foot of unprotected south or west-facing glass is not just a passive opening to the outside temperature. It is an active thermal radiator, injecting solar energy directly into your living space at a rate that has nothing to do with the air temperature outside. Your AC could be fighting a 75-degree Celsius exterior on an overcast day, and your windows, still receiving diffuse solar radiation, would still be pumping heat into the room. Your thermostat doesn't know this. It only measures air temperature. It can't see the radiant heat pouring off your sun-warmed floors, furniture, and walls, the secondary thermal wave that begins after the solar radiation has already entered and been absorbed. By the time your thermostat registers the problem and signals your AC to respond, the heat has already been deposited. The compressor fires up, removes some of the heat, cycles off, and moments later the windows deposit more. This is not a malfunction. This is your home's thermal physics working exactly as designed, and working against you. Let's put real numbers to this. The average American home spends between $400 and $600 per year on air conditioning alone in moderate climates, climbing to $600 and $1,000 or higher in warmer states like Texas, Florida, Arizona, and California. The Department of Energy estimates that heat gain through windows is responsible for approximately 25–40% of that air conditioning expenditure in homes without window treatment. Using conservative middle ground figures, if your annual cooling bill runs $800, window-driven heat is responsible for roughly $280 to $320 of that sum. That's just from the heat physics. The AC efficiency penalty, the overcycling, the shorter equipment lifespan, the compressor strain from fighting solar loads that shouldn't exist, adds further hidden costs that don't show up as a line item but appear eventually as a $4,000 HVAC replacement. Now narrow the focus to just 4 south or west-facing windows in a typical home. 4 windows, each approximately 15 square feet, each receiving 4 to 6 hours of direct summer sun per day. Run the BTU math from the Lawrence-Berkeley data through a standard electricity cost of 0.14 per kilowatt-hour and the annual cost of the heat those 4 windows introduce, heat that your AC must then remove, comes to somewhere between $700 and $1,000 per year. From 4 windows, not from a manufacturing defect, not from a broken seal, from standard, functioning, perfectly normal windows doing exactly what glass does. That number compounds differently when you understand that every year this continues, it continues at full cost. There is no depreciation. The sun does not get less effective. The physics do not improve with time. The $700 to $1,000 that left your household last summer will leave again next summer and the summer after that, with the same quiet efficiency that nobody told you to question. If your air conditioning runs longer than it used to, if certain rooms never cool down no matter what you set the thermostat to, if your electricity bills climb every summer even though you haven't changed your habits, if your AC unit died younger than it should have, your home has been telling you something in the only language it has. It has been telling you that it is fighting a battle from inside, not outside. That the enemy was never the summer air. That the wall you've been trying to reinforce is not the one that's failing you. The window is the wall that failed. It has been failing you for years. The question now is what you intend to do about it. And as it turns out, the answer costs about $15 and ships in 2 days. There is a question that sits underneath everything in this story, and it deserves a direct answer before we go any further. If a $15 product exists that can cut your cooling costs by up to 80%, backed by NASA research published in 1974 and validated by decades of institutional use, why doesn't everyone know about it? The answer is not complicated. It is not even particularly surprising once you understand the economics of the industry that was supposed to tell you. The residential energy efficiency industry in the United States generates approximately $60 billion in annual revenue. That number sounds impressive. It sounds like a lot of people working very hard to help you reduce your energy consumption. Look more carefully at what that money actually buys, and a different picture emerges. HVAC repairs and full system replacements account for roughly $24 billion of that market. These are not one-time purchases. They recur every 10 to 15 years, and the service visits, maintenance contracts, and refrigerant refills that precede the replacement generate revenue in every intervening year. A well-functioning HVAC system that lasts 25 years because its load was dramatically reduced by window film is, from a business perspective, a customer who fell off the revenue map. Insulation and weatherization services make up another $18 billion. This work requires contractors, specialized equipment, and materials that homeowners cannot realistically purchase or install themselves. The labor component alone accounts for 40 to 60% of the cost. A homeowner who discovers that their window-sourced heat load was the primary driver of their discomfort and addresses it for $15 per window has permanently exited the insulation contractor's pipeline for that problem category. Smart thermostats and connected home energy devices represent $11 billion. These devices, priced at $150 to $300 and climbing, have created an entire ecosystem of companion applications, energy monitoring subscriptions, and replacement upgrade cycles. They are genuinely useful products. They are also specifically designed to manage the symptoms of a home's thermal problems rather than eliminate the source. A thermostat that learns your schedule and adjusts accordingly is a sophisticated tool for more efficiently fighting a battle that, with $15 of window film, you could have largely stopped fighting in the first place. The last major segment, energy auditing and consulting, adds another $7 billion. Professionals visit your home, run blower door tests, examine your insulation, assess your HVAC performance, and produce detailed reports recommending, with notable consistency, the services provided by the other segments of this same industry. In this entire $60 billion ecosystem, there is no meaningful commercial constituency for a $15 DIY product that a homeowner applies once and does not replace for a decade. There is no contractor labor, no subscription, no follow-up service call, no manufacturer with a marketing budget, no connected app generating behavioral data, no recurring revenue of any kind. The product is structurally invisible to an industry organized around the opposite of it. There is a principle in commercial product development that rarely gets stated publicly, but governs nearly every marketing dollar in the consumer goods space. A product that solves a problem permanently and cheaply is a product that generates one sale. A product that manages a problem expensively and continuously generates a customer. The energy efficiency industry has, with remarkable consistency, organized itself around the second model. Consider the smart thermostat. Nest, Ecobee, and their competitors have spent hundreds of millions of dollars on consumer marketing, retail placement, and media coverage over the past 15 years. The pitch, save up to 23% on your energy bill, is genuine. The technology works. The marketing budgets exist because the products cost $200 to $300, generate recurring software and data revenue, have aspirational brand identities, and require periodic replacement. Now consider window film. No national television campaigns, no Super Bowl ads, no influencer partnerships, no app, no company spending $50 million to tell you it exists, because the economics of a $15 product with a 10-year lifespan cannot support that kind of marketing infrastructure. The margin per unit is measured in cents, not dollars. The sale, once made, is finished. There is nothing to upsell. This is not cynicism. This is simply how commercial marketing allocates resources. It follows the money. And the money has never been in telling you about the $15 solution. When the abstract arguments about industry incentives start to feel theoretical, there is one case study that brings everything into sharp, undeniable focus. In 2009, the Empire State Building, one of the most recognizable and heavily studied commercial structures on Earth, underwent a comprehensive energy retrofit. Among the measures evaluated by the building's engineering team and their partner Rocky Mountain Institute was the treatment of the building's 6,514 windows with window film technology. The result was documented, published, and widely circulated in commercial real estate and sustainability circles, even if it never made the front page of your local newspaper. The window film treatment reduced the building's solar heat gain by approximately 68%. The building's overall cooling load dropped significantly. Air conditioning systems that had been straining against the thermal assault of New York's summer sun were suddenly operating in a fundamentally different thermal environment. The cost of the entire window treatment program was recouped within a single year through energy savings. Not 5 years, not 10, 1 year. And the film continues to perform year after year with no maintenance, no service calls, no subscription, and no replacement cycle. The Empire State Building's management team publicized these results. Commercial real estate developers across the country took note. The technology moved briskly through corporate, institutional, and government channels, the same channels through which it has always traveled since NASA's 1972 breakthrough. The residential consumer market once again received no memo. That chart above deserves a moment of stillness. The solution with the fastest payback, the lowest cost, The longest effective lifespan and the zero maintenance requirement is also the solution that receives the least marketing attention, the fewest contractor referrals, and the smallest share of the energy efficiency conversation. This is not a coincidence. Of all the parties positioned to tell you about window film technology, perhaps none is more conspicuous in their silence than your electric utility company. Think about the relationship you have with your electricity provider. They know exactly how much energy you consume and exactly when. They know your peak usage hours. They know which months your bills spike. They have your email address, your mailing address, and in many cases your phone number. They send you newsletters about rate changes, outage notifications, and, with increasing frequency, tips on how to save energy and lower your bill. Those tips, when they arrive, are remarkably consistent. Set your thermostat higher during the day, run your dishwasher at night, replace incandescent bulbs with LEDs, seal gaps around doors and windows with weather stripping. Not once in the decades since NASA's research was published has any major U.S. residential electric utility included in their consumer communications a recommendation to apply $15 window film to their south and west-facing windows. Not once. This is worth sitting with. Your utility company has a stated mission to help you use energy wisely. They have regulatory obligations in many states to offer efficiency guidance to customers. They produce elaborate energy efficiency programs and marketing campaigns, and in none of that output, not the email, not the newsletter, not the rebate program, not the efficiency audit, does the most cost-effective residential cooling intervention in existence appear. Ask yourself who benefits from that silence. A utility company's revenue is, in most regulatory structures, directly tied to how much electricity its customers consume. A company that successfully guides its customers toward dramatically lower consumption is a company that has reduced its own revenue base. The regulatory incentive structures vary by state, and some utilities do operate genuine conservation programs. But the fundamental tension between a utility's financial interest and its customers' energy consumption is not a theory. It is built into the business model. When the cheapest, most effective, most durable solution to residential cooling costs is also the solution that most permanently reduces grid dependency. The silence of the entity that profits from your grid dependency is not puzzling. It is predictable.
Strip away all complexity, all corporate language, all regulatory nuance, and the situation reduces to a single principle that anyone who has ever run a business will immediately recognize. If a solution generates recurring revenue, it gets marketed. If it doesn't, it doesn't. A new HVAC unit generates recurring revenue. The installation fee, the maintenance contract, the annual tune-up, the eventual refrigerant recharge, the replacement in 12 years, and the new maintenance contract after that. Every node in that chain has a business with a marketing budget, a sales force, and a financial interest in ensuring that homeowners think of HVAC as the answer to their cooling problems. A smart thermostat generates recurring revenue. The device purchase, the companion app subscription, the data licensing to energy companies, the hardware upgrade when the next generation launches.
Nest spent $150 million on marketing in its early years. The category now has Super Bowl advertising, home improvement store end caps, and celebrity endorsements. A spray foam insulation contractor generates recurring revenue through professional service relationships, the initial installation, the follow-up assessment, referrals to the HVAC contractor, referrals to the energy auditor, and referrals back from both of them. The ecosystem is self-reinforcing. Window film generates a one-time transaction of approximately $15, requires no contractor, installs in 20 minutes with a spray bottle and a squeegee, lasts 10 years without degradation, and solves up to 40% of a home's cooling problem at the source rather than the symptom. There is no margin in that transaction to support a national marketing campaign. There is no service relationship to cultivate. There is no subscription to renew. There is no contractor who benefits from recommending it because the contractor's own business model depends on homeowners not solving problems themselves. This is not a conspiracy in the dramatic sense. It doesn't require a room of executives deciding to hide a product from the public. It requires only that every commercial entity in the chain follow its financial incentives. and those incentives, without exception, point away from $15 window film and toward every more expensive, more complex, more recurring alternative. The market, left to its own devices, will never correct this. The information gap will not close on its own, because the entities with the resources to close it are the entities who profit from its remaining open. You are sitting on the other side of 50 years of structured silence. NASA proved the technology worked in 1974. The government used it in every federal building by 1983. The Empire State Building cut its cooling costs by 68% and recovered its investment in a single year. The physics have not changed. The product has not degraded. The technology has only gotten cheaper, more accessible, and more effective. And for all of those 50 years, the $60 billion residential energy efficiency industry continued selling you larger air conditioners, thicker insulation, smarter thermostats, and annual audit subscriptions, all of which treat the symptoms of a problem that a $15 product addresses at the source. You were not supposed to do the math. You were not supposed to trace the incentives. You were not supposed to ask why your utility company's energy efficiency newsletter has never once mentioned the intervention with the fastest payback and the longest lifespan. But you have. And now you know exactly where to start. The film is on Amazon. It ships in 2 days, one afternoon, a spray bottle, and a squeegee. The industry had 50 years to tell you. They chose not to. The choice of what to do next belongs entirely to you.